Okay, so the question is how I got into research synthesis, and there are two things that brought me into this field. The first is that I used to work in a hospital, and I was involved in clinical trials, and I realized at some point that most of what we were doing was silly, in the sense that basically we were trying to see if p-values were statistically significant or not, and we would make decisions about drugs and about treatments on the basis of whether or not the p-value is statistically significant. And in fact, that really doesn't tell us very much at all. If a p-value is statistically significant, then the only thing that we really know is that the treatment has some effect greater than zero, but we don't really know whether that effect is of any substantive importance or clinical importance or not. And in meta-analysis, people were focusing on the size of the effect, which is really what we care about. When we ask if something is effective, what we really have in mind is whether or not it has a clinically important effect. And meta-analysis, by focusing on the size of the effect, actually addresses the thing that we care about and that we thought we were addressing with p-values, but in fact, we weren't. I'm very concerned about the fact that people misunderstand statistics for heterogeneity. Because when people ask whether or not the effects are heterogeneous, what they really have in mind is how much does the effect size vary from study to study. Is it the case that the treatment has pretty much the same effect in all populations, or is it the effect that it varies moderately, or is it the case that the size of that the treatment effect varies, where it has only a trivial impact in some cases and a moderate impact in other cases and a major impact in other cases? And people seem to think that that's addressed by the test of significance for heterogeneity, or that it's addressed by I-square. And in fact, it is not. I-square does not tell you how much the effect size varies. That's a very common mistake, but it's a mistake nevertheless. And there are statistics that will tell you that. For example, one of them is the prediction interval, so that you can actually say that in some populations the effect is trivial, and in some it's moderate, and in some it's substantial. But we have to make sure that we use the right statistics and interpret them correctly.